Now let us begin with the next chapter, signal conditioning, data acquisition systems and data conversion. Let us first discuss about signal conditioning. Let us say what you mean by signal conditioning. To know about signal conditioning, let us consider a block diagram of the general measurement system. This block diagram of a general measurement system consists of three stages. The first stage is the sensor transducer stage, the second stage is signal conditioner stage, and the third stage is data presentation stage. The sensor transducer stage or the sensor transducer combination, it detects the physical quantity which is to be measured and it is converted to an electrical signal. Now, sensor is always used in association with transducer. The sensor detects the physical quantity or non-electrical quantity which is to be measured, and the transducer, it converts that physical quantity into an electrical signal. Now, this data presentation unit or the stage, it consists of indicating instruments or recording instruments or displaying instruments. But here we cannot use the converted electrical signal of transducer directly. So the electrical signal may require certain modifications such as amplification or attenuation, etc. So this necessary modification is carried out in the intermediate stage, which is called as signal conditioning stage. Now let us define signal conditioning. Signal conditioning may be defined as the process of modifying the output signals from the transducer into usable and satisfactory signal using amplification, attenuation, non-linearization, linearization, or multiplication by another function. Then what is the necessity of signal conditioning? The necessity of signal conditioning may be due to these reasons which are mentioned here. Sometimes the output electrical signal of a transducer may be too noisy due to the electromagnetic interference. So it requires to be filtered or it requires to be attenuated. So the signal conditioning stage does this function. Sometimes the signals may be too small. The output signal of a transducer may be too small in magnitude. So it requires to be amplified, and this function can also be done in signal conditioning stage. Sometimes the signals may be non-linear or they may be of analog type which are required to be converted into digital form. And signals may be in digital form and they need to be converted into analog signals. And in order to improve the quality of digital signals, so signal conditioning is required. So these are some of the necessities of signal conditioning. Now let us see the processes adopted in signal conditioning system. The following processes are usually adopted in signal conditioning system. The first one, protection. Suppose if the magnitude of output electrical signal from a transducer is very high, then it may damage the next unit or element, so which is required to be protected. For example, if a high voltage or high current signals are fed to the microprocessor, it will get damaged. The microprocessor can be protected by employing a series of current limiting resistors or else by using a step down transformer if the voltage is very high. Second one, getting right type of signals. Suppose if the output signal of a transducer is of analog type and if it is required to be converted into digital form, then we must use analog to digital converter. Or else suppose if the output signal is in the digital form, and if it is required to be converted into analog signal, then we have to use digital to analog converter. Then third one, getting correct level of signals. Sometimes the output electrical signal of a transducer may be very low. So it is required to amplify this signal. So for this amplification, operational amplifiers or op-amp are widely used. Third one, elimination of interferences. Some undesired signals or disturbances may be associated with the output electrical signal of a transducer, and these needs to be eliminated. Such interferences are eliminated by the use of filters. Fifth one, manipulation of signals. The output signals may be non-linear in nature, and these need to be linearized, and also vice versa. Now let us discuss about functions of signal conditioning equipment. The signal conditioning equipment may be required to perform the following functions on the transduced signal. They are amplification, modification or modulation, impedance matching, data processing, and data transmission. So let us see amplification. Amplification means increasing the level of signal or enhancement of the signal level. Here, sometimes the output electrical signal of a transducer may be very low in magnitude, so it requires amplification. Then second function is modification or modulation. It means to change the form of the signal. The signal may be smoothed, linearized, filtered, or converted into either analog or digital form. Third one, impedance matching. The signal conditioning equipment arranges the input and output impedances of the matching device so as to prevent loading of the transducer and to maintain a high signal level at the recorder. Fourth one, data processing. That means to carry out mathematical operations such as addition, subtraction, differentiation, integration, so on, before indication or recording of data. Then fifth one, data transmission. That is to transmit the signal from one location to another without changing the contents of the information. Now, we know that basically there are two types of transducers, passive transducers and active transducers. In case of passive transducers, like strain gauges, potentiometer, resistance thermometers, and so on, some external excitation is required because these transducers don't generate their own voltage or current which is required for their operation, and the excitation is provided from the external sources. And the active transducers like tacho generators, thermocouples, and so on, they don't require excitation from external source because they produce their own electrical voltage or current. The excitation required for passive transducer may be either from DC voltage source or AC voltage source. So depending on this, there are two types of signal conditioning systems, DC signal conditioning systems and AC signal conditioning systems. So let us discuss about these two types of signal conditioning systems. So let us see DC signal conditioning system. Let us consider the block diagram of a DC signal conditioning system. So this block diagram has the blocks like majorant, transducer, bridge, DC excitation source, calibration and zeroing network, DC network or DC amplifier, low pass filter and DC output. Here let us consider an example of strain gauge which is used as a transducer. Now this strain gauge, it measures the applied force or pressure in terms of change in resistance. So now let us consider force or pressure as measurement and transducer as strain gauge. So the output of a transducer or the output of a strain gauge is the change in the resistance. That change in the resistance is measured by means of a bridge like Wheatstone bridge. So obviously the Wheatstone bridge requires DC excitation source. So now when the bridge is balanced under normal condition, when the bridge is balanced, it gives zero output. That means the galvanometer reads zero voltage. When force or external pressure is applied to the strain gauge, the resistance of the strain gauge changes. And because of this change in the resistance of the strain gauge, the bridge becomes unbalanced and it produces the voltage. So this calibration and zeroing network consists of potentiometer and galvanometers. So when the bridge becomes unbalanced, so we get some output voltage which is given to the DC network or DC amplifier. This DC amplifier amplifies that output voltage of the bridge and it is given to the output through low pass filter. Low pass filter, it attenuates, it filters out the high frequency signals. Now let us discuss about AC signal conditioning systems. Unlike DC signal conditioning system, in case of AC signal conditioning system, AC source is used. So this is the block diagram of standard AC signal conditioning system, which has measurement, transducer, bridge, which is AC bridge here, calibration and zeroing network, AC amplifier, phase sensitive modulator, low pass filter and AC output. Here there is an AC source which is given to carrier oscillator which gives high frequency AC supply. So now here also let us take an example of strain gauge used as a transducer. So measurement is the input force or pressure, and as we discussed in the previous case, strain gauge converts the applied force or pressure in terms of change in the resistance. Now this change in the resistance is measured by means of AC bridge. So to this bridge, a high frequency AC supply is given through this carrier oscillator. So now when force or pressure is applied, then the resistance of the strain gauge changes, so which unbalances the bridge, and the galvanometer, it reads it, the bridge becomes unbalanced and the galvanometer or the voltmeter gives the output voltage. So that output voltage is amplified by means of AC amplifier and it is further modulated or demodulated by means of phase sensitive modulator, to which again high frequency AC supply is given through carrier oscillator, and then the signal is passed through this low pass filter where high frequency AC signals are filtered, then it is given to the output.